11.1, applying the counting principle and permutations. Objective, to use the counting principle and permutations. Let's take a look at an example. A sporting good store offers 3 types of snowboards, and here are the 3 types. And after you pick the snowboard, you want to pick 2 types of boots, soft or hybrid. How many choices does the store offer for the snowboarding equipment? So once you get your board, then the 2 choices are soft and hybrid, and same with here. This is called a tree diagram. So here are your options: all mountain and soft, all mountain, hybrid, freestyle, soft, freestyle, hybrid, carving, soft, carving, hybrid. So in the end, you have 6 choices. This is called the fundamental counting principle. And it says if one event occurs in m ways and another event occurs in n ways, then just multiply both events like this. Now, if you have 3 or more, then you just multiply each of the 3 events, the number of choices that you have in each of those. Let's take a look at this example. You're framing a picture, and you have a frame, 12 ways to do that. You have a style, and you also have the mat that you want to use. So the frames is 12 times 55 times 11. And when you multiply all these numbers, the answer is 7,260 choices that you have. Let's take a look at the counting principle in this problem. A license plate, the Texas license plate, has 1 letter followed by 2 digits followed by 3 letters. How many different license plates are possible if letters and digits can be repeated? All right, so in the first one, there are 26 letters in the alphabet, so there's 26 options for this first. As far as digits, there are 10 digits. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Same here. And then we have 26 here, 26 here, and 26 here. And what we're going to do is we're going to multiply all these, and this is how many choices we'll have. I'll let you do that. Number of plates. How many different license plates are possible if digits and letters and digits cannot be repeated? So for the first, we're going to have 26, and then we're going to have 10. But once we use a letter and a number, then the number here, there's only going to be 9 left to choose from because we've already used that 1. Once we've used a letter, we now have 25 to choose from, 24 here, and 23. And we'll just put this in our calculator and we'll find out how many possible there are. I'll let you do that as well. Your turn. Pause. And here's the answer. Pause. And here's the answer. Let's talk about permutations. An ordering of n objects is a permutations of the objects. Here's some examples of a permutation of the letters A, B, and C. This is where order is important. A, B, and C. We could have another arrangement where A is in the beginning, and then we have some arrangements where B's in the beginning, B's in the beginning, and C and C. And there are 3 choices for the first letter. After the first letter, there's 2 choices. So first letter, there's 3 choices, then 2 choices, and then once you put those 2 letters in place, there's only 1. And that's what we have: 1, 2, 3, 4, 5, 6 options that we have. This 3, 2, 1 is called 3 factorial. This is the symbol factorial. And in general, n factorial is defined where n is a positive integer and it follows this pattern. Let's take a look at to find the number of permutations for in how many different ways can the bobsledding team finish the competition. So there's 10 teams. And so there's 10 options for first place. And once the team gets picked there, then there's going to be 9, 8, 7, 6, 5, 4, 3, 2, 1. And it looks like I have an extra here that I don't need. Okay, and this is another way to say 10 factorial. And so we would just put this in our calculator and we would find the number of ways. Let's take a look at how the B is a little different. In how many different ways can 3 bobsledding teams finish first, second, and third? Okay, so now we don't want to talk about all the 10 teams. We just want to see how many ways that we can get first, second, and third. So there are 10 again. And once the winner's picked, then there's only 9 options for second place. And once second place is picked, it's only 8. So this number is much smaller than this number. Okay, a permutation, the number of permutations that we just were talking about, is written this way. And it's read permutation of n chosen r. Permutation of n chosen r. And this is the formula for it. It's n factorial divided by n minus r factorial. So if we talk about a problem where we have 5 people and we want to find out how many choices we have for first, second, and third, then you can see this is 5, 4, 3, 2, 1 divided by 2 factorial. And you can see now this is the first, second, and third, just like we were doing before, and that answer is going to be 60. Okay, so let's look at the judges in a science fair. We have 10 contestants, similar to the bobsled problem, and how many different ways can first, second, and third place be. And we're going to do this with a permutation formula. So we have 10 contestants, and we're only going to choose them 3 ways. This is what the formula tells us to do. And remember, this is 10 factorial, so it's all of these numbers divided by 7 factorial, and in the end, you're going to get 10, 9, and 8, which is 720. Let's go ahead and practice just using the formula. So a permutation of 5 chosen 3 will be 5 factorial divided by 5 minus 3 factorial. Now this is going to be 5 times 4 times 3 times 2 times 1. And then this is going to be 2. So this will be 2 times 1. These will reduce. And then we're going to have 60 as our answer. Over here, number 5 is going to be 4 factorial all over 4 minus 1 factorial. So this is going to be 4 times 3 times 2 times 1. And then this is a 3 factorial, 3 times 2 times 1. So we can see we can reduce here, and the answer is 4. All right, let me show you that your calculator can do this calculation as well. So let's go ahead and use a calculator for permutation of 5 chosen 3. So what I'm going to do is I'm going to go to math, and then I'm going to go to the column probability, and then I'm going to choose the second option, and I'm going to put the number 5 here, and then I'm going to put 3, so a probability of 5 chosen 3, and then enter, and you can see we get 60. Let's do it again. So I'm going to do second, enter, and now I'm going to alter my permutation and just have 4, and then go over here and change it to 1, and then enter, and you can see I get 4. Your turn. And here's the answer. You could have done it the long way, or you could have used your calculator if you wish. Your turn. And here's the answer. Your turn. And here's the answer. Let's talk about permutations with repetition. If you consider the letters E and E to be distinct, there are 6 permutations of the letters red E, green E, and blue Y. So there are 6. There are 3 choices. So this is 3 times 2 times 1, or 6. But really, these 2 E's are interchangeable. So in the end, we really only have 3 distinguishable permutations if we don't call it red E and green E. So each of these permutations correspond to 2 of the original 6 permutations. So see, these are really the same. So to get the number of distinguishable permutations, what we do is we take 3 factorial and we divide it by the number of repetitions, 2 factorial, and then we'll get 3. Okay, so here's the formula for the permutations with repetition. You take the factorial and then you divide by all the number of times that letter repeats. Let's go ahead and do this problem. Here's the formula right here. So for number 1, we have 1, 2, 3, 4, 5. So this is 5 factorial. And it looks like m is shown twice, so it's 2 factorial. And I shows up twice, so that's 2 factorial. So this will be 5 times 4 times 3 times 2 times 1, all divided by 2 times 1, and then 2 times 1. So these will 2 times 1 here. The 2 will reduce, and then we'll do some reducing here. So this will be 6 times 5, which is 30. For Tallahassee, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 factorial. And then we have A that occurs 1, 2, 3, 3 times. And then we have L that occurs twice. And we have an S that occurs twice. And we have E that occurs twice. So A, L, S, and E. And I'll leave it to you to go ahead and find that answer once you have that. Your turn. And here's the answer.